Welcome to the Futurati podcast. Any member of the Futurati is somebody who believes in the power of the future. We know there's a better world ahead, and we indeed have the power to make it so. In our podcast, we talk to the best minds in the world about the most urgent problems facing mankind today, and we hope you learn as much from them as we do. I'm Thomas Fry, a professional futurist and keynote speaker.
And I'm Trent Fowler, a machine learning engineer and author. Thank you for joining us. Good evening, everyone, and thank you for listening to the Futurati podcast. Tonight, we're joined by Scott Young. Scott is a blogger, teacher, and the author of Ultralearning. Scott rose to fame for the MIT Challenge, in which he successfully completed MIT's 4-year computer science curriculum in just 1 year. Since then, he's helped thousands of people achieve their career goals and be more productive. If you enjoy this interview, please don't forget to like the episode and subscribe on YouTube or wherever you get your podcast so that we can keep bringing you this great content. Scott, thanks so much for coming on the show.
Oh, it's great to be here.
Why don't we hear a little bit about your background, your interests, and what brought you to the place you are today?
Yeah, so I mean, that's a broad question. I've been a writer for 15 years on my website, largely focused on learning, but also about like goal setting, productivity, self-improvement. And I guess the thing I'm most known for now is taking on sort of these what I call ultra learning challenges, where you're trying to learn something in a kind of compressed time frame using unusual methods. So for instance, the MIT challenge was a project I did about now 10 years ago, where I tried to learn MIT's 4-year computer science curriculum in 12 months by taking their free materials online and trying to pass the final exams. And I also did another project trying to learn 4 different languages in 1 year with the kind of method of not speaking English while I was traveling. And I actually did that with a friend. And I wrote a book about it. I wrote a book, Ultralearning, which not only detailed my own projects, but also lots of other people's, including you. I think you make an appearance in the book with your STEM Punk project.
Page 22.
Yeah, exactly. So, I mean, I should be asking you about your projects and stuff as well.
Yeah, can you say the next answer in Korean? I just wanted to see if you...
Yeah, probably not. I think, it's funny you bring into that, because I think that Korean was definitely the worst one of the 4 that we did. So of the ones that go, let's have an interview, that would be my hardest. And that actually happened to me because when my book came out in Korean, the Korean translator or publisher did some promotion for it and got a Korean newspaper to interview me. And most of the interview is in English, but then they're like, okay, now for the Korean section. And I was like, oh man, this is like, again, 7 years ago, haven't done as much practice as I should since. And being the 4th stop in 4, it was definitely like, that one was like, all right, if I was basing the evaluation of the trip on that leg, I would say it was not nearly as successful. But Spanish, first one up, was pretty good.
Yeah, Scott and I both have some grounding in Korean. I lived in Korea for 2 years, so theoretically,
oh nice, wow.
Theoretically, we could do this interview.
Yeah,
but I would want to limit
한국말 조금 할 수
있어요. These days. Mm-hmm. Yeah, so that surprises me that Korean was harder than Mandarin. Was it just because that was the end of the project?
No, I don't think that there's any like intrinsic difficulty. It's just that it was literally that Korean was after Mandarin, and the difference too is that I don't know how much we want to get into this, but I did this with a friend. And so we all had like our picks of which countries, so I was really interested in going to China and my friend was really interested in going to Korea. I initially wanted to go to Japan and learn Japanese. And so I think that influenced our motivation as well, because when I hit China, I was like really hit the ground running. I'd already done tons of flashcards. I'm learning the characters. I was like intense about it. And then by the time, after 3 months of doing that really intensely, to just kickstart it up again in Korean, I did do the studying. I did do that, but it just was not the full, full-throated effort at that point. And my friend, on the other hand, that was like the country that he really studied hard in because he cared about it. And I think also just, it's funny to think about, because when I describe the sort of process of like, okay, you land there and then all of a sudden we're like taking videos of each other only speaking in that language, it just sounds like it would be impossible to sustain for more than 2 weeks. So the fact that we got through 9 months in 3 countries before it was kind of like, okay, this last one's a grind, I think, itself was a little bit of a revelation for us that, talking to people there, they can't imagine doing, okay, I can't imagine going in and only speaking this language for, a couple of weeks.
Yeah, that was basically the approach that I took. I was teaching English, so I had to speak English while I was there.
Yeah.
But I mean, any chance that I got to speak Korean, I did. And I was in a little small town where most people, their English was not very good or basically non-existent. So I just had no choice from the beginning to order things in Korean and talk to people in Korean, ask questions in Korean. And that really helped a lot.
Yeah. And I mean, I shouldn't be too hard on myself. Like if anyone wants to see, we have videos where we have 15-minute, 20-minute conversations with people after. I just think it wasn't, Korean is a difficult language, I think, compared to European languages.
Oh yeah.
And I just the Mandarin, I was really I was, swinging for the fences on that one. And then Korea, it's okay, I'm in a little dorm room. We've got bed bugs. It's kind of all right,
oh, no.
this trip is almost getting to close. Just gotta keep at it. But I mean, I think that's also one of the things too, is that I like to take on these challenges almost as the perspective I want to take on it is not oh, look at me, I'm all great, but just sort of well, what could you do if you just tried to do this? And so I think there's definitely flaws and failures and, ways that things didn't meet the ideal in any of my projects. But I think that, what people appreciate about them and what I like to do is just kind of, well, what if you tried this and tried to document it and see what happens? Because I think when we were starting the project, I really didn't want to go on record making any kind of claim about what level of proficiency we'd get. So I was definitely not doing what Benny Lewis was doing. It was I'm going to be fluent in 3 months. Right. And then, the nitpickers in there are kind of is this really fluent ? After it. Whereas for me, it was well, I have no idea. I haven't done this before. Maybe it'll work. Maybe it'll completely fail.
So how much has this idea of adding technology to what you're doing entered into your thinking? I mean, learning something, if you have this little AI bot that's sitting on your shoulder that looks like a parrot that's talking back and forth to you, and you can have these conversations with it in 4 different languages, I guess, or 5.
5 French too, right? You speak French.
Yeah. So this idea of somehow speeding up the learning through technology rather than just banging your head against the wall, getting it in there.
So I have mixed thoughts on technology and learning, because I think that on the one hand, it's clear if you look at the projects I did that technology played a huge role. The MIT challenge would straight up not have been possible if MIT decided, okay, we're not going to upload all of our courseware for free. That was the entire conceit of the project, was that they were already doing this. So if you rewind the clock back to the 1980s, I couldn't have done it. You have things like maybe the great courses, which is, some professor having a badly audio recorded, rambling lecture, but there's no assignments, there's no tests, there's no evaluative criteria. How can you even attempt to benchmark off of an actual degree? Whereas for me, the MIT challenge was just this is new. I don't know if anyone's ever tried this before. And similarly with the language learning project, I mean, there were lots of tools. I can talk about flashcards in Mandarin. That played a huge role especially for acquiring the knowledge of the characters, which is a really flashcard amenable task. And even in, lots of the other things, there was technology in terms of, getting to the country. Having Google Translate on your phone has incalculable value, because if you have to look through a dictionary, it's just not at fluent speed. Right. You can't talk to people. So this whole idea of okay, well, I'm going to just start speaking from when we get off the plane. Either you have to have a much higher initial level of ability, which I don't recommend going in with 0, but we were closer to 0 than we could have been with that. And also, it's just way harder if you're okay, I can't use any English, but I can't use any tool for explaining myself. And I've got 15 words and I have to be I need cold medicine because I'm sick right now. How do you deal with that? Right. Whereas if you type in cold medicine in your phone, you can say it to the person and get some progress. So on the one hand, it's obvious that technology plays a big role. On the other hand, I'm less technologically optimistic than perhaps some people in the educational space. And so it's kind of funny you mentioned that, because I'm working on some research right now, but it basically centers around how it's my opinion that we've kind of underestimated the transfer problem in a lot of tasks. And so there's a real tendency to like, let's substitute the actual work of learning this with some game, which is popular and fun. And maybe you get more people to engage with it. But I worry that if you're not actually getting people to perform the cognitive skill that is required in the real situation, it's just a waste of time. Like it doesn't actually help very much. And so, I'm really critical of Duolingo in my book. And I mean, I haven't used their app in a number of years, so maybe it's gotten a lot better and I've got egg on my face after I say this. But I remember after the trip, because it had kind of gotten popular after we did the trip, and I was going to Italy for a little stay, and I was like, oh, I should try Italian Duolingo. Let's try it out. And like one of the tasks was this, it had like a word box where you put the words in Italian and there was an English sentence and you had to drag them to form the sentence. And this to me was just like, it was the kind of activity that someone who doesn't really like have a good understanding of this cognitive science part would be like, oh yeah, this is, helping me learn the words. But when you think about what you actually have to do with your head, with your mind in order to perform this task, it is nothing like what you actually have to do when you're speaking a language. First of all, you're using all these cues that are not available in the real situation. So for instance, the first word is always capitalized. So you get that one for free, right? You always get to put that one there because it's the one that's capitalized. And then the second, it's, you're dealing with like 5 or 6 words in English and 5 or 6 words in the other language. So being able to recognize that this word means this noun in the sentence is a much, much easier task than here's the English word I want to recall. And it could be any possible set of sounds in this other language. What was it, right? And to say it with enough precision to do it. So I think that Duolingo is an example of this because I feel like it's just, I don't really mean to pick on Duolingo specifically, but I think it's just a more general trend in education at large, and we can dig into this, to really emphasize the learning problem of like, how do we get you to perform on some criterion task and not to deal with the transfer or validity problem of, does that criterion task matter at all for the thing that you're actually doing? And often I think the answer is no, it's not actually what you need to do. And so there is this kind of trend, I think, with education and stuff to just like, to make tools, to make games, to make apps, to try to make things more enticing, more fun. And I think these can be done well, but I think there's also a peril that, we're just inventing things that like look like this is what you need to do to learn a language, and it's not really what you need to do. And maybe that's fine for the people who are never actually going to speak a language, like that, this is just something to play with on their phone. But I think it helps to at least be honest about that, so if that's what we're doing.
It's always occurred to me that people that make the language software, their whole marketplace is built on good intentions. The success rates are really tiny in most of the language software. So I've been thinking a lot about this idea of having a conversational interface, being able to talk back and forth to a bot, and the bot then picks up on what things you're conversant in, what things you've learned, what skills you currently have, where you're deficient, and what it'll take to bring you up to speed. If we can get to that point, and it's a big if. I mean, we've got lots of details to work through, but if we can do that, then that theoretically should be a much more efficient way of learning things, because it will know exactly what you should be focused on, because so there's not so much redundancy on things you've already learned.
Well, I agree in principle. I mean, I think that it's was it Paul Bloom? I'm trying to remember the first name, but Bloom's study about the 2 sigma problem in education, which is just basically that like it's very hard to find educational interventions that don't just do as well as one-on-one tutoring. And the problem with one-on-one tutoring is it's too expensive, right? Like that's why we have classrooms with 30 kids and 1 teacher, because one-on-one is too expensive. And so if you could make automated tutors, like there's just enormous potential there, because then you have, poor villagers in some developing country able to access, someone who has created a system that allows them to get guided instruction at like, the elite college level in the United States. And I think that has huge opportunity. I think that, my feeling is that like I've seen some of the stuff with like is it GPT or GTP? GPT. GTP is another thing, is guanosine triphosphate. But the stuff that they're doing right now, I think, is very interesting, but I don't know whether we're there yet with the technology to do that. I have seen, like, I was reading a book that was talking about transfer, and this is like from, this is way before deep learning and all that kind of stuff, but it was from Anderson and Singley, the transfer of cognitive skill. And this was this idea they were trying to investigate learning, but they're doing it through the context of a computer tutor, of doing a computer task. In this case, it was using an editor, word editor. This is pre-GUIs, so this is like, they were kind of hard to use back then. And so they were seeing mistakes people were making and then kind of creating this complicated kind of expert system, like, if then tree, to figure out, okay, you're making this kind of mistake, therefore I'm going to give you this example or give you this instruction, or don't do this, or watch out for this. And so I think the idea of having this kind of replacing the teacher or tutor with computer software is definitely interesting, and it's been around for a while. But again, I do want to say this. I think that there are certain domains of learning which are like really amenable to this kind of highly standardized thing, like mathematics, maybe computer programming, where there's very much a right answer and there's a limited number of operations you can move. So the mistakes are bounded. Whereas, I think for learning a language right now, I think it is still hard because this is one of the things that I also found difficult about Duolingo, is that on the situations where you get to where you type in the answer, it's very unforgiving. So it kind of goes to the opposite direction, that if you didn't say the sentence exactly the way that they wanted you to say it, then it's wrong. Even though real languages don't work that way. There's usually synonyms. There's usually like, you could have said it with, the word order didn't have to be exactly that way to be correct. And so, they're kind of stuck between a rock and a hard place. Either they make the assessment way too easy and then you're not really testing yourself, or they make it kind of artificially hard and then you create their own problems. And so I don't know. I think it just depends on how much you think the learning that we need to do fits more into the kind of mathematics paradigm that's, really amenable to this kind of clear bounded types of error modes. And you can think about it versus, something like tennis, which it totally doesn't fit that model at all. Right.
Right. So I suspect that building a tutor for something like philosophy and open-ended reasoning would be an AI complete problem. Like you might just have to build something that's approximately equivalent to a human being in order to tackle that at all. But I do think that you could roll it out in stages. You're right that certain domains are just more amenable to this approach than others. And I'm sure it's no coincidence that math and computer science were the places where we first saw these efforts rolling out, automated textbooks where you could actually run code in the browser, that sort of thing. Mm-hmm. But it seems like there are places where you could pluck some of the lower hanging fruit. So, I mean, you could, for example, monitor attention in an automated fashion and just notice when people are not paying attention any longer. Or you might be able to pinpoint the specific problem that they're making. So maybe the algorithm is not able to actually coach them through the process of solving this problem correctly, but it can say, it looks like they're screwing up at this place right here. They don't have an accurate model of how this process works.
Well, so, I'm going to shift the topic a little bit, because I think automated tutors are interesting, but I think there's actually a lot of interesting opportunity for technology that isn't quite like that. So I really like the possibility of tools like live streaming as a way of kind of getting scale at this sort of apprenticeship model, because although it is the case that it's often helpful to have the feedback from the tutor, this is what you're doing wrong. Just being able to watch someone do what they're doing, right? Especially if it comes with some kind of explanation for it, especially if it's a highly mental task, you're not just like building something with your hands, but you're performing some cognitive work and then you get the answer. And so, the analogy or the example that I like to point to, which I think is really fascinating, is there's a whole community of people who try to play video games as fast as possible. And the interesting thing about this is, just if you look at the progress of how they've been doing it, many games that were, the best example is Tetris, which was a super popular game in like the 80s or 90s. And, everyone was playing Tetris back then. And now far, far fewer people are playing it, but they're much, much better at it. Like if you watch any videos of these people, they break the game where, they get to too high a level. So now you can't even see any of the pieces. The screen's all glitchy and they keep playing through it and stuff. But the thing to me that's interesting is, because I don't have a particular interest in Tetris, the thing that interests me about that is that this is sort of a domain of human innovation, and what is pushing it? What is pushing the progress forward, even though you have a much smaller group of people working on it? Again, no financial incentives or anything like that. And it seems to me to be that, first of all, you have live streaming, or just sort of the rule that in order to count as having accomplished something, you have to have a video record of having done it. And so that in and of itself allows anyone to reverse engineer. So as soon as someone figures out something, they can see how you did it. And then, so it's sort of like the patent system on steroids. Right. And then also there's these communities of online forums, so you can get super niche interests that allow this kind of discussion, so that, innovations can spread throughout the network quite quickly. Whereas before, if you wanted to get good at Tetris, well, I don't know, maybe your buddy, he's pretty good at Tetris, he can tell you some tricks. But I mean, it's just that local network graph can't transcend that. So I think there's a lot of opportunities for technology that they don't even involve AI, but just involve using the kind of ways that we learn in a more organic, analog way, but leverage the scale effects of the internet, and leverage the scale effects of, being able to take one thing that previously you could stand 10 people around some guy doing it, and that would be all the people who could see it, to, now you could have 10 million people watching that person, or you could have, pages of dissection of exactly how they did it,
I've actually been thinking in terms of assessment bots. And if you have a conversational interface with something, then you talk back and forth. And so it's assessing what you're knowledgeable on and what you're not. And it also assesses what your interests are, what things capture your imagination and what things you couldn't care less about. And being able to then, this idea of being able to quantify what a skill is, I think is so interesting. Because it's not straightforward at all. And so what skills are you going to need in the future? Where are you lacking? So I think a lot about, in terms of the same technology that's automating our jobs out of existence is the same technology that's going to be creating new jobs, where it's going to be opening up the opportunities for creating new businesses and new industries. And so... but it's all add-on skills. I mean, we're adding on new skills that we need to be able to function in those new industries. And so how do we do that quick and efficiently? And say that, I want you to give the answer in 10 words.
Well, I think that's a really good idea if we can make it work. Is that 10?
That's 11. Well, and it seems to me like there might be some major ground to be traversed here by marrying these two approaches. So you mentioned live streaming, right? And so I'm thinking about that, and then as Thomas is talking, I'm thinking about ways you might apply what he's discussing to that process as well. So I mean, if you had somebody live streaming themselves solving some sort of cognitive task as they're coding and they're sort of narrating their process. And then people can ask questions. The conversational interface is able to do some semantic parsing and understand kind of what the confusion is or what their interest is. Maybe, prioritizes the greater degrees of confusion up in the live stream chat so the person sees it more clearly, that sort of thing, or is maybe able to flag people when their attention is waning and let them know that they're losing the thread. So that wouldn't involve any serious advances in artificial intelligence. It's just a way of sort of combining a couple of different advances to make a platform that, in theory at least, could substantially improve learning outcomes.
Well, I guess the way I think of it is that, the leading institutions that are trying to change how we learn things are higher education. So, as like I went through, the MIT put their courseware online. But I think often the challenge is that, higher education often, not always, but often works to to signal what kinds of abilities you have, rather than, okay, the knowledge you learn in school is literally the reason you're getting paid more at the job, because, a lot of it doesn't transfer. It's not particularly useful for the specific job that you actually end up doing. And I think anyone who thinks about the work they do can reflect on that being at least somewhat true. And so to me, I think that the way we actually become skilled at our jobs and develop the kinds of competencies you're talking about, especially in like a really, high skilled society where, what you do is not just something you can just pull a guy off the street and pay him $16 an hour, throw on some overalls, and there you go, I can show you in 10 minutes. We're dealing with skills that require years to develop, and we don't really know exactly how to develop them. But I think the model of apprenticeship, speaking broadly, of just being in a real job environment where you're given tasks of increasing complexity and you have a peer group that kind of knows how to do it and you can kind of ask for help. And, I'm not specifically trying to bring back this formal master apprentice relationship where you're indentured to this person for 7 years or something like that. But I think that this general idea of kind of learning by doing and being in the real environment could be augmented by technology, because one of the major problems with that right now is that taking your most productive workers, pulling them off the assembly line, so to speak, to go train a bunch of new people is enormously costly. I was reading an essay that was talking about apprenticeship in Germany where it's successful, and they were saying, yeah, it works, but it's also super expensive. Like, you have to invest an enormous amount of money per apprentice to actually get these results. And so I think, there could be a lot of interesting ways that organizations could, maybe like their best person, instead of mentoring one person, does set up a live stream where they're narrating how they do certain projects and this kind of thing. And so you get the best possible person showing how they code and deal with this kind of problem. And, maybe some other people help make it into like a more usable document. So you don't just have to watch like 20 hours of live streaming to get the point. Maybe there's something there. And so I just use the speedrunning community as a little bit of an analogy, just because it seems to me to be a situation where innovation has occurred at a really breathtaking pace because of technology, but not technology in the sense of like, that was directly how they were getting better, but just in terms of how knowledge was getting disseminated across a network of people, how innovation was accumulating. And so to me, that's, I think, where there's a lot of really untapped potential right now that, I don't know exactly what form it would take. I'm not like peer pitching a startup, but I think that there's a lot of interesting possibility there.
So there's like a technology for access, which is sort of what you're advocating for. Then there's like a technology for process, which you're more skeptical of. Is that fair?
Well, it's not that technology for process is necessarily bad. And I really like your idea of having the chatbot. I don't know whether we're there yet. Like I remember there was someone who made it was like a text adventure game made with the GPT-3. And it was really interesting, but it lacks some of the intentional content that we normally expect from a conversational partner. So it's a little bit like interacting with someone in a fugue state. Like, they produce great sounding sentences, but it's very much like one sentence after the other. There's no real goal. And so in this particular game I remember playing, and I was just, playing around with it. It was really interesting because it could kind of create these colorful scenarios, but it didn't work as a game because you could always and then I pull out of my pocket a magic wand and teleport to the finish line or something. And it would just run with that. It would just say, oh yeah, great. And so I think, to me, if like, I'm not an AI researcher, so feel free to give this zero weight, but to me, I feel like what we have with deep learning is we've solved a really important breakthrough that the mind uses to do this kind of pattern-based inferences and, generating speech and motor action. And I think it's very, very fascinating. But I think there's probably, if I could go 100 years in the future of my spaceship, there's probably a couple other key conceptual breakthroughs that need to happen in order to have the some of the qualitative features that we think of human cognition, of just being able to hold goals in place and decide between different courses of action and making plans and things like this. I think that's an important part of speech and talking to people, but I haven't seen any real applications that do this in the GPT-3 kind of super sophisticated fluent speaking way yet. I know obviously you can do customer service chatbots but those are almost like the expert systems of earlier days where they look for a few keywords and you say, did you mean this? And they send you a link to an FAQ article. It's not quite the same thing, right?
So we've been speculating on different kind of learning. The idea that you could put on a full body spandex suit, and then it would have certain triggers that would trigger your muscles in your body. So you could be programmed to be like an Olympic gymnast, and it would, as you start doing your flips and everything, naturally you'd have to do it a few times and crash and burn a few times before your muscles would get up to speed. But being able to trigger the right muscles at the right time would be a real interesting way to do physical learning in ways that's not possible right now. And so, that could translate into lots of other physical activities as well. So anyway, this is something kind of on the cutting edge of reality.
Well, I mean, I think it's really interesting. I think it's kind of also the problem of robotics. Like, how do you get robots to move in human-like ways? I think part of the difficulty is that we're like, especially in the realm of physical action, but I think you could also make the argument even more cognitive skills are similar. There's a lot of spanning in terms of you're not just making a decision, like some motor plan, like I'm going to do this action and then just executing it from your imagination. It's this kind of constant, there's a little bit too much tension here. I need to balance, do this and this and this. And so I think it's that calibration of those feedback that what is actually being learned in a physical skill. And so if, let's say I, get who's that great American gymnast of Bynes, I think is her last name. But if I got a suit or with her that like mapped all of her muscle coordination, Simone Biles. Sorry. Yeah. Okay. But if I got like a suit on her that just like recorded every single little muscle fiber twitch and like recorded her doing some, triple somersault thing. And then I put the suit on myself, and assuming I'm in good enough shape that I'm not going to rip all the bones in my body. I think it wouldn't work just because all of those muscular movements are also calibrated for her exact size and weight and distribution and these kinds of things. And so I think and even just the terrain and stuff that you're on, like if you're on a certain terrain and it gives a little bit more, your body instantly adjusts. And so I think this kind of, to me, I think what would be really interesting is how you can facilitate learning a skill, a physical skill, more efficiently, perhaps by recognizing what kind of feedback settings the body has wrong. And I think that's an area where we're not really that far. I know that there are situations where like coaches and stuff will videotape someone and make but it's a kind of a crude measure, right? It would be something far more interesting to look at, like, okay, if you're moving in a certain way, actually you do this action with this muscle just a little bit too. So you need to like have something that will recalibrate you so that you'll do it in a different way. So I think there is potential for this, but we're obviously dealing with like a pretty speculative territory when it comes to how technology might affect future motor learning.
Right. And I wonder if it might not be expandable into cognitive skills as well. It's interesting that you brought that up. So I've often wished that there were some way to stimulate patterns in my brain that map onto patterns in someone else's brain. So I have a friend who's a mathematician, and I've been thinking about this for a while because he sort of tutored me in math for a bit. And I wondered if it might not be possible to hook us both up with, transcranial magnetic stimulation electrodes, right? Yeah. And then looking at the parietal lobe or whatever is flashing in his brain as he's solving some sort of problem, like, might you be able to do the same thing in me and achieve some sort of measurable speed up? And I think the big problem there is just, math may not be represented the same way in his brain as it is in mine. And maybe just lighting my brain up is not really the right way to do it, but it's an interesting angle, I think.
I mean, again, I think like while we're speculating on things, yeah, that sounds really cool. But I think, again, and now we're treading into more areas where I have no expertise in, but if you look at, let's say, the blood vessels and the capillaries in your body, even identical twins don't have them in exactly the same place, right? They're not generated via some, like there's somewhere in your genome that says, okay, this capillary in like my left index finger is going to branch at exactly this cell. It's rather that there's some kind of generative algorithm that has a little bit of noise that gets the job done. It knows that it has to link everything together. And, I'm not going to go into embryology, but I think that that's probably true of the nervous system, right? Like we're born with way more neurons than we have in our adult life. And there's this massive culling of neurons, and it's based probably on sensory feedback that like, these are unhelpful patterns. So the brain is probably not created via some extremely rigorous, put this neuron here and it does X. It's rather kind of like make a lot of neurons that are wired in roughly this fashion, and then just use the normal mechanisms of feedback and apoptosis to just weed out all the neurons that don't do what we want it to do. And so I think about that. Like, I think that, if you were to map, let's say, someone's skill onto your brain, onto someone else's brain, perhaps there's enough kind of isomorphism there that you could get some kind of mapping. And I mean, I know that they've done some work where they've used people's visual cortexes, and they've kind of read off some of the magnetic readings of people's visual cortexes and use that to see what they're looking at in like a really low res picture version. But even that seems to be like you're doing some kind of training for that person. I don't know whether you can apply the exact same algorithm to every single person, but the visual cortex is organized topographically, roughly. So, maybe there's enough similarity there that like, if you put it on your brain, onto my brain, I could see what you're seeing or something. Maybe that's possible. I don't know. But in terms of like a motor skill, or especially when we're talking about learning of quite specific things, my feeling is that they probably are quite specific patterns of activation in the brain. Like they just can't be super, okay, there's just a little patch here that lights up when you do algebra, because there's not enough patches, right? Unless, you know what I mean? I think there's probably a situation where you have an assemblage of, thousands or maybe even hundreds of thousands of neurons that are all, in activation at the same time. And that just happens to be the key that unlocks a very particular kind of movement or thought. But it may not be the same neurons at all in someone else. And so even if you were to get the transmagnetic stimulator on both sides, maybe it's, you're thinking of oranges and this person's going to be thinking of, bicycles or something like that. I don't know. So
no, that's a fair point. One of the things I wanted to talk about was introspection. So you said that, in the future, maybe the immediate future, you see possibilities around live streaming and people sort of narrating their process as they go through solving some sort of cognitive task. Mm-hmm. And that's highly non-trivial. So one of the things I'm always talking about is that introspection is a skill which most people suck at, and that it matters a lot. And one of the, if I may say it this way, innovations in my project, the STEMpunk project, was I spent a lot of time thinking about when I had screwed up something. And I started making these little flow charts and trying to track down the cognitive errors. And I would sort of try to go through the process of making the correct cognitive maneuver. I would try to do it like reps in the gym or something. And I didn't take that super far, but as far as I've been able to tell, nobody's really tread that path or thought very much about that. And so it seems like you would be looking for people who are really, really good at introspecting their thought processes and figuring out exactly the moves they're making, because a lot of that it takes a lot of work to see when your brain is, when it's missing a detail or when it's shying away from a conclusion. It takes a lot of time to notice those little movements, cognitive movements. And so I just wonder if you've given any thought to that, if you think it's improvable
Well,
somehow.
First of all, I'll say that, I haven't actually tested this idea. As I said, I don't have like a startup to pitch for like, this is what we're doing. We're doing this new kind of, everyone's hooking up your live streaming to your big company and everyone's going to learn better. So I don't know. There's probably lots of problems with it. I'm sure someone's tried it before and they can tell you, oh, these are the reasons why it doesn't work that I haven't thought of. But I don't think what you're talking about necessarily applies. I don't think that it's the case that you need someone that has a superhuman introspective ability in order to be able to like narrate their cognitive processes, because in my mind, it's kind of the same thing as apprenticeship, right? Like it's, you know, the person does it, right? And then, you know, okay, well, why did you do that? I don't know. I did it for this reason. And I don't think that when apprentices do things, they often know why they are doing things exactly the way they're doing. And no, that's how you do it. You do this first and then you do that. And so I don't think you need to have a really good kind of theory of why you're doing what you're doing in order to be a good kind of exemplar or model for someone else doing a certain behavior. You just have to do it. They have to watch you, and they have to try. Obviously, you know, you don't just learn it instantly just by watching someone either. But I don't think it's the case that I need to know why I'm doing every single thing that I'm doing. Like that might be true if I were to try to reduce it to text, what I'm doing. But I think the whole idea of live streaming video is that there is so much tacit skill that goes into performing in our professional lives that is hard to codify, that's hard to write down in terms of, you know, in terms of expert systems, in terms of like, okay, if you do this, then do this. So if you just watch someone doing it, doing some kind of typical tasks or doing some sorts of things, then you'd be able to do it. And I think that there's probably a little bit of explaining required for a cognitive task, in the sense that, you know, if you did something that it wasn't obvious why you did it, maybe you could say, well, I'm thinking I'm going to have this problem, so I'm going to have to do this right now. So there's maybe a little bit more narration than it would be if it was, you know, purely physical. But at the same time, I think that's another reason why if you were doing this, it would work a lot better with skills that do cross the kind of skull, right? Like if it was just, okay, I'm just staring at a chalkboard for an hour and then I write an equation and right. Be like, correct, right? Like then it's very hard to do this. But if you were dealing with someone programming and you have a thing of, you see all the things they're typing, you see what they typed and what they're doing, this kind of stuff. And I think it's possible that you could, if you had this kind of recording, and especially I think the thing that makes the speedrunning community work so well is that there is a kind of competitive atmosphere of trying to reach certain kind of criteria and this kind of thing. So I don't know whether that's the thing that would prevent it from translating, because maybe you work on some work task and no one's ever trying to do that exact thing ever again. And so it's, you know, it's not that helpful to watch the video, and maybe the more abstract principles of why you were doing that particular task aren't apparent. But I think that just that ability to watch someone doing what they're doing and get feedback, and the ability to scale that is a potential use of technology. I mean, the apprenticeship and this idea of learning through watching someone do something through an example, I think this is how we've learned, you know, way before the education system. This is all of human history. So I think we're kind of designed in a certain way to learn that way. And so I don't know. I think introspective ability, though, to your point, is something that a lot of people take for granted, that if you're doing something, you should know the reasons for why you're doing it. Maybe that's just a communicative norm that like we expect people to be accountable for their own actions. And so we just have this sort of assumption that everyone knows why they're doing what they're doing, because to not assume that would be to just invite people being like, I don't know, when they did something that was obviously a transgression, and then it would prevent us from punishing them and this kind of thing. So maybe there's just a little bit of a white lie there in how we deal with things. But obviously, in terms of how the brain actually works, we have no idea what's going on most of the time in most ways. And most things just arrive to us as a fully finished answer of do this. This is the right thing to do, with not really that many intervening layers of cognition where there was a lot of calculating and figuring out. Calculating and figuring out is the exception, not the rule. Like usually you do something because it just occurs to you to do that, and you have no idea how you arrived at it, as opposed to some long drawn out process of reasoning through various alternatives.
So when you look at the path of progress, apparently Shakespeare was the first person that actually wrote about characters talking to themselves. Mm-hmm. And so that people always did that, but they didn't ever talk about it. And so that was the first time that they ever anybody ever created characters that talk to themselves. So that's the first form of introspection. And this idea of learning a skill, whether you're a machine, making things on a big machine or whatever device you're working with, learning those skills is a painful process. I mean, it's being an apprentice, learning how to bake bread or lay cement or whatever you're doing. That's such a slow and arduous process. Now, when we look at how things have progressed over the last few years, we're thinking in terms of downloading individual skills. I mean, so how would we reverse engineer? We put this little thing on the side of somebody's head that's an expert on this topic, and then it reverse engineers all of the stuff, and then you put it on somebody else's head, and then they suddenly know that skill. But if you take it to the next level, then it's the idea of downloading an entire person's brain, everything that's in your head, and being able to upload it into somebody else, which is probably a long ways away. And
like then, brain to brain?
Yeah. So, and I think we could fit it all into one of these micro SD cards now.
Yeah.
But being able to do that, then that's kind of the path of progress. I mean, that's the way that people are thinking in terms of doing things like this. And then naturally there's all kinds of problems. I mean, there's privacy issues about you downloaded this person's brain, then you get all their kinky, quirky stuff that they shouldn't know about anyway. So how do you filter all that out? But anyway, that's kind of the path of progress, the way I look at things.
Yeah, I mean, I think you're talking about like brain emulation. There's sort of two separate things, like going from one person's brain to another person's brain, which I have no idea how you do that. It sounds like a very interesting engineering challenge, but I think it deals with the problem that I was saying before, that if there's no hard-coded instructions, like a blueprint, right? Like if you have a blueprint at a fab factory that's making microchips, they make exactly the same microchip every time, and they need enormous like precision. You can't have any dust or anything because it'll screw it up, to make these chips exactly the same every time. I don't think it's plausible at all that that's how our brains get made, right? Because nature and evolution they don't care whether they can make exactly the same. They just need to make something that works, right? And so I feel like instead you don't have a blueprint, you have more like a recipe, right? That you make bread, and the bread is never going to be exactly the same in terms of the crumb structure and the crust and this kind of, like, it's not going to be identical. You don't slice it and like there's a hole in exactly that part each time you make it. But if you follow the recipe well enough, the bread tastes more or less the same, and it's good enough for a sandwich. And so I think the good enough for a sandwich rule is how the brain is actually made. And so I think that would create impressive engineering challenges, because we don't care about just having a brain that's good enough for a sandwich. We want it to be us, right? And so if you want to make it in one brain to another, I think that would be fiendishly difficult to get this, again, like think of all the capillaries in your arms, like getting someone to make exactly those capillaries in another arm would be challenging. And that's an even larger structure than the neurons and synapses and stuff, which are, they're tiny. And so I think there's, I think there's more potential for someone doing an extremely high resolution deconstruction of someone's brain and making a digital copy of that maybe we could simulate on a supercomputer or something. But I think that itself, I think, there's a lot more scientific and engineering breakthroughs, obviously, that have to happen before that's possible. But I tend to think that there's more than maybe some futurists think in terms of stuff in between. Like you read papers now and there's people talking about how maybe synaptic strength isn't even the basis for memories. I was reading a paper the other day that was talking about how it might actually be related to DNA gene regulation that's coming back up. And I don't remember the studies they were looking at, but they were, you can even look at things like caterpillars. You can do some classical conditioning experiments on them. They turn into a butterfly. They remember the things that they were when they were a caterpillar, and they turn into goop in the middle. So I think, whatever's happening there, it's we're not even quite sure what it is. I was reading another paper that was talking about how this is again not the consensus opinion. This is by some heterodox neuroscientist, but he was talking about how there is evidence in the Purkinje cells, which are in the cerebellum, that they can individually encode time delay data, so that like if something happens 1 second or several milliseconds after, they can store that internally, which implies that like the neurons are themselves more computationally complicated than maybe the neural nets that we have, where they're just sort of this atomic unit that fires or it doesn't and integrates input. That like maybe there's some computation going inside the neuron, and I don't know. I don't want to be saying that any of these things are definitive. Just that I think that there's still a long way to go in terms of both neuroscience and I think on the AI engineering end to get to a point where, they're lasering our brains and then we're living in virtual reality. That would be cool though, but I think it's still a ways off.
So Scott is less sanguine about these possibilities than we are, I think.
Well, I just think maybe they're like 200-300 years off. I just don't know whether we're going to be alive
to next year, maybe. Or
Yeah.
year after.
Yeah. Well, I heard Elon Musk. You can just write him a check and he'll get it set up for you in the next 5 years.
Well, I mean, with Neuralink, we should be able to download anything, upload. And I'm pretty sure that he's going to be able to teach those pigs that he's working with how to drive a car.
Well, I think one thing that I think is more possible is a kind of a computer brain interface, which is I think what Neuralink is proposing, which is not attempting to extract our consciousness or really even necessarily download something in the way that, okay, now it's in my brain. But you could imagine, for instance, if you were performing, okay, so a good example is right now, if I wanted to go speak another language that I don't speak, I could turn on my phone and use Google Translate, which is imperfect, but it works reasonably well, better than not knowing anything at all. And I can speak my audio into it, and then it'll come out in the language of the other person, and then they can speak into it. It'll come back to me. And like, we have this technology now. It doesn't work perfectly, but we have this now. So it's not impossible to imagine that if there was some way of kind of reading that, they do like really fine-grained fMRI scans on you, and they can tell you're thinking these words right now, right? And if they had some sort of like, okay, microphone, so I think these words, and then they just translate and I just speak it. And when the words the other person speaks, it just goes into my head and automatically. I think that's something that's, not quite as far off. That might be something that, 10 years from now, maybe they're doing. I don't know if they can get over all the regulatory hurdles of implanting electrodes into your brain, which I think is another thing.
Yeah. So you have become famous as a guy who tackles all these major projects. What's on the plate now? What are you planning for the future?
Well, it's funny because we've been kind of talking about it. I think this is just me top of mind, talking about all the things I've been immersing myself in research on. But I've become very interested in this idea of learning by doing as a kind of, not really as an alternative to the current education system, in that like everyone should be just learning by doing, but kind of recognizing that this is often what we struggle with when we're learning. So, real basic example, if you are in a classroom and you have a test to study for, many students will just look over their notes. They don't do the practice questions for the test, right? So there's this kind of mixture of the practice questions for the test are what you really need to do to be good at the test, but there's resistance to do that. And it's a lot easier to, look over your notes or re-highlight things or skim things. Like I've seen people in the library, this is how they study. And I think this is something that you can extrapolate to all sorts of scenarios. So like I was saying, it's much more challenging and there's more obstacles to speaking a language with an actual person than to sitting on the bus playing on Duolingo. It's more difficult to, get a real job where you're doing programming projects than it is to, watch some video on YouTube where someone's talking about programming, or, you buy a book and you keep it on your shelf and you're like, yeah, I'll flip through that at some point. And so it's something that I've been thinking a lot about these ideas of apprenticeship and learning by doing, and kind of thinking about them in a little bit of a different way than maybe I was when I was thinking about doing the MIT challenge, where I really kind of took for granted that, well, universities are important. They must be teaching things the way that they ought to be taught. So That's sort of what I've been reading tons of books on that topic recently.
So have you ever thought through the potential of creating a Scott Young AI teacher bot that will coach people to become super learners, to learn things really fast, and then you have your own branded AI bots, and you could sell like a million of them, and they would be all over the place.
This sounds like a great way to make money. I don't know. Well, again, as I said, I still have some reservations that we're at that level yet with AI, but we're getting there close. So this isn't like the scanning the brain thing. This is something that I fully expect in 10 years that things like Siri and those kinds of things are much better than they are now. And they're already, I mean, pretty good. If you had told me when I was 15 that we have this thing Siri and you showed me how it worked, my mind would have been blown, right? So just the fact that we just take it for granted that it exists right now and with its strengths and limitations, I think is something in and of itself. But I don't know. Personally, I think that's also an interesting question because I find I have conversations with people, and like I wrote this book, and to me, I don't really see myself as having a unique method. Like I'm the one who's cracked the code, so to speak. I rather just see it as like I'm a guy who's really interested in learning, and so I read a lot of those big textbooks that people don't want to read about cognitive science, and I'm like, oh, this is what they say. So I think I don't know. I think to me, the idea of wanting to learn more effectively is always going to be a little bit of a niche interest. If you think about you go to the bookshelves and look at what's on the front table, it's not really books about this, right? And so I think there is always going to be just a subset of people who are like really keen into understanding what the process is and trying to apply it to other skills. And so I think that, I hope that like a book like mine can give them some of that entryway into some of these ideas. And I don't know. I think for the average person, it's probably better to not try to like deal with some really complicated synthesis of like, this is the best way to make, Flash or something, but like, okay, if you're going to be studying for a test, you should do the practice questions. Like that's just one sentence. That's what you should do. So I don't know how much of a chat bot I could help with. I think there is your idea of having the chat bot for particular subjects is more fruitful just because there's a lot more content there to impart. Whereas I think the, advice for how to learn better that I can easily write down in a book, I tried to put it in a book, but I mean, if you eliminate all the stories and just try to reduce it down to a cheat sheet, it wouldn't be super, super long. So I don't think it's necessarily that there's a really sophisticated general method for learning things better. Rather, there are a bunch of kind of useful tools and heuristics, and you have to know when they work and when they don't work. And I think more than anything, you have to have the will and interest to apply them. I think that second part is perhaps more important than the content of the ideas themselves. And that's a big part of the reason I try to do these stories and stuff to encourage people.
So it's just going to be a lot of work then. I mean, people.
Well, it is a lot of work. I mean, it is.
People wanted to come listen to this podcast to find the easy way.
I tricked you.
Yeah,
I tricked you. No,
we want that pill.
Yeah. Well, everyone wants the pill. I think, but I think there's two ways of putting it, because I feel like, you do have to do the work. There's no escape for it. There's a reason I called the book Ultralearning. And to me, it was because I really didn't like the idea of just calling it like, effortless learning or like something like that, because I know that that's what people would want. So I know that would sell more copies. But to me, the whole hallmark of it is that the techniques that work, and I could go through a whole list of them, they tend to be somewhat harder than the thing that you might do on its own. And the efficiency gains, I think, are worth it. So studying effectively, even if it's more mentally taxing for that brief duration, is much better than spending 10 times as much time in the library, wasting your time and failing on a test. But I think that is a trade-off that you have to consider.
So you're saying that your next book will not be the 4-hour college degree.
Oh, that would be something.
That would sell a lot of copies.
Yeah. But I mean, I think that's an inherent trade-off in many pursuits, not even just learning, just the fact that I think you can you can talk about product, like effectiveness of your actions and strategy, right? And I think that if you speak about it in the vein of like, well, if you were going to try to accomplish goal X and you use an effective strategy and it takes half as much time, that's great, right? That's a savings. But I think the thing that takes half as much time is usually not like, oh, you sit on the couch and you just play on your phone and it's super fun and it doesn't require any effort, right? It's usually more along the lines of like, well, if you were serious about it, you could do it this way and get the result faster. And so I do think that there is that bit of a trade-off. And so I think that, I think my message is, for instance, if we're speaking about learning languages, I think that the average person, if they applied an effective approach, could learn a language. A lot of people don't think they could learn a language as an adult. They could learn a language, speak it conversationally, and they could probably do so in a shorter time frame or shorter number of total hours than they might naively think from their old high school Spanish classes that they remember sitting for many, many hours for. But on the reverse side, I also don't think it's effortless to do so. I don't think that there's some way of doing it that you just don't have to go through that difficulty of, okay, let's struggle through a conversation here.
Right. Well, fantastic. Thanks so much for joining us today and imparting this wisdom.
Thank you. Thank you for having me.
Yeah, this is great. Thanks.
All right, ladies and gentlemen, I hope you enjoyed this interview with Scott Young. Don't forget to leave us a like and subscribe on YouTube or wherever you get your podcasts, and we'll see you next time.